So, if you are watching this, you missed our introduction to soils presentation, day 1. I'm going to cruise through this relatively fast, so make sure you pause it to write things down because you can use notes on quizzes. All right, so first of all, it is not dirt, it's soil. Dirt is dead. Dirt is misplaced soil. Dirt is what you drag in on your shoes. Soil is an entire biome of living organisms and is essential for human civilization. Okay, be that way. So, what are we going to learn? If you're taking notes, you don't need to write this part down. This is just an overview of what we're going to learn. We're going to learn about soil. Why is it important? We're going to learn what is soil. We're going to learn the difference between sand, silt, and clay. Those are going to be our 3 things for today. Tomorrow will be, or the next video, you'll be learning other things. You'll learn what a soil profile is, soil horizons are, what soil color means, and how we're running out of soil, and that's really, really bad. So first, what is soil? As I said, soil is not dirt, but soil is a mixture of rocks, minerals, and organic matter. That organic matter is the really big part of soil versus dirt. Dirt is dead, soil is alive. There are more organisms in a handful of soil than there are people in the world. There's about 1 billion per teaspoon of soil, billion organisms per teaspoon of soil. So you've got 7 billion organisms in 7 billion backtrack. You've got about 1 billion organisms per teaspoon of soil. So if you have 7 teaspoons of soil, you have 7 billion organisms. So a handful of soil, more organisms than there are people in the world. So, as I just said, organic matter is important. It's the difference between soil and dirt. Why should you care? Well, first of all, soil is the #1 support for plants. So if you have any interest in gardening, in caring for a lawn, soil is vital. It anchors plant roots so they won't fall over. Also stores nutrients for the plants. Plants need 16 elements and 13 of them can come from soil. Wow, I didn't fix that typo. Soil stores moisture for plants is what that should say. And as I said, 1 teaspoon of soil can hold 1 billion bacteria. Soil is alive. Something important to remember. So where does soil come from? Just have parents, soil has parents. And this parent material is actually unweathered material soil is formed from. Hard rocks that are usually found under the soil are usually considered the parent material. And just like how your biological parents have affected who you are as a person, as in like what eye color do you have, what hair color do you have, what you look like, how tall you're going to be. Parent material, the biological, well, not really biological, but the parent material of soil is going to affect a lot of what soil is going to be. However, just like you are affected by your environment, soil is also affected by its environment. So how it was weathered down is important, just like what physical characteristics it has. So particle sizes, again, you don't have to write these 3 words down because we're going to dive deeper into each one. We have sand, silt, and clay. So first of all, we have sand. Think of the beach. When you go to the beach and play in sand, you do want to write this part down. When you play in sand, think of those particle sizes when we're talking about sand. We can feel and see the individual pieces in sand. It feels gritty. It doesn't stick together very well. When you hold it in your hand, if you try to get it to form, it doesn't work very well. There's also larger spaces between particles. This provides really good drainage. So for example, when it's on a beach, when the waves come up over it, the water can filter through the sand. Next, we've got silt. Think flour. Silt is soft, it's powdery. Particles can only be seen with a microscope. So if you look at a handful of silt, you can't really see the individual particles. It forms clods, but it crumbles if it's really wet. So you can get it to form a ball, but it doesn't stay in a ball very well. So it doesn't stick together too well. It has good water holding capacity, meaning it can hold a lot of water inside of it. Clay, think art class. When you're in Mr. Z's class and you play with clay, this is what the particles are really small, microscopic. You can't really see them at all without a microscope. Think smaller than silt. They stick together very well. That's why we make like pottery and stuff like that out of sand, silt, and clay. heavy. Part of this is it holds water really, really, really well. It also has large surface area. Sand, as behind me I have an egg. Sand is big. So in that size of an area, we've got 3 particles. This is all the surfaces. Silt is a lot smaller. So if we cover the same amount of area, we have a lot more surface area. And clay is even more so. Because the particles are so small, there's more surfaces. They also can get a lot closer together because the sand, no matter how close together I draw it, there's going to be a lot more gaps because it doesn't fit perfectly together. Clay has really bad drainage. As I said, clay can get a lot closer together because it's a lot smaller. There's a lot less gaps in between. That means water can't go through as well. Sand, water can travel through really easily. Clay, it can't. Silt is somewhere in between. Now, I don't want to say no, but very, 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 very few soils are 100% sand, 100% silt, or 100% clay. Most are a mixture of that. We usually call that loam. But they have a percentage of each type of particle size. So that ends us where we are. It ends us where we are. That ended day 1 of our soil chat. If you missed day 2, hop onto the next video, and that will hit through day 2. Again, make sure if you didn't write everything down, go back, pause it on slides, and write everything down. You can use notes on quizzes. Have a super fantabulous day.